Ever get that feeling? Like something you remember just isn't quite right anymore.
Like a detail shifted.
Yeah, like a movie title is suddenly different. Or a brand from your childhood has like a new spelling.
That mismatch between memory and reality, huh?
Yeah, and it turns out it's surprisingly common.
You're not alone in feeling that, not at all.
And like our source for this deep dive points out,
It's almost like a glitch in reality, they say.
yeah, and they use some interesting examples, like the Berenstain Bears.
So many people remember it with an E at the end.
Berenstain, right?
Yeah, and Febreze. Some remember a different vowel sound.
Oh, interesting.
Even the Statue of Liberty?
Yeah, some people swear it was on a completely different part of the island.
Exactly.
So these glitches in reality, as our source calls them, they've really taken off online. People call them the Mandela Effects, which is kind of a cool name.
It is. It is.
So this brings us to the big question we're tackling in this deep dive. And it might sound a little out there, but bear with us. Could the work being done at CERN, with that huge, Large Hadron Collider, could that have anything to do with these weird shared memory glitches?
Right. It's a fascinating connection.
Yeah, I get to see.
It's speculative, definitely, but fascinating nonetheless.
And we're going to be exploring it using excerpts from this document called How CERN Broke the Internet and Reality as We Know It, .pdef.
Now, it's important to remember this source has a specific viewpoint. It suggests a link between CERN's experiments and these changes to reality, as they put it.
Right, so our goal is to really unpack these theories, dive into the quantum mechanics and parallel universes and all that heady stuff the source talks about, and hopefully give you a better grasp of these ideas.
A clearer understanding, yeah.
So right off the bat, the source throws out some wild explanations for these Mandela effects. One of them is the multiverse.
This idea that our universe isn't the only one.
Right, that there are other universes out there.
Exactly. And this is where our source really reflects the current multiverse theory. It suggests that for every choice, every outcome, there's a separate universe. Every path not taken, taken in another reality.
Whoa, that's a lot to take in.
A whole tapestry of realities branching off at every single moment.
So this is where it gets really interesting. Our source asks, could our universe somehow have bumped into another one?
Almost like merged with another reality.
A reality that's almost identical, but with tiny differences that we're suddenly noticing.
Right, like two versions of the same story overlapping.
And suddenly we're confused about the details.
Exactly. It's a really far out theory, but it's one way to try and explain why so many people share memories that don't quite match up.
Okay, so if we're even going to entertain this possibility of universes bumping into each other, our source points the finger, metaphorically, of course, at CERN.
And more specifically, at the Large Hadron Collider, the LHC.
So tell us about this thing, this LHC. What is it exactly?
The LHC, it's an incredible feat of engineering. Like the source emphasizes, it's the largest machine humans have ever built. We're talking a 27-kilometer-long circular tunnel.
A 27-kilometer loop underground.
Yeah, imagine that. Almost a marathon-length tunnel underground, crossing international borders. And its purpose, to accelerate particles, like protons, to nearly the speed of light.
Nearly the speed of light.
99.9999991%, to be precise.
Wow, that's mind-bogglingly fast.
Yeah, almost impossible to grasp. And they smash these particles together, releasing tremendous energy. And from those collisions, all sorts of other particles are created, and scientists study them.
So they're basically smashing things together at unimaginable speeds to see what happens.
In essence, yes. And by studying these collisions, they can learn about the fundamental building blocks of the universe and the forces at play.
And has the LHC been successful in doing that?
Oh, incredibly.
Oh, good.
It's led to new particle discoveries that have filled gaps in our understanding of particle physics. We're talking about the Standard Model, which is a best explanation so far for the fundamental particles and forces, except for gravity.
So really groundbreaking stuff. But as our force also points out, generating that kind of power, it raises questions about possible unintended consequences, right?
It does. The source talks about the immense energy needed to run this huge machine and the possibility of some weird side effects, let's say.
Weird side effects from smashing things together at the speed of light. What could possibly go wrong?
Well, it's natural to wonder what might happen when you concentrate so much energy into such tiny spaces. Early on, there was skepticism about the LHC. People were worried it could create microscopic black holes or even rip holes in space-time.
Micro black holes. That sounds like something out of a sci-fi movie.
It does, but scientists took those concerns seriously. Most agreed that any black holes created would be incredibly tiny and disappear almost instantly, so not really a threat. But those fears were definitely out there. And this brings us to one of the LHC's biggest achievements, the discovery of the Higgs boson.
Ah, the Higgs boson, famously elusive particle.
Yeah, it's a big deal. The source describes it as being associated with the Higgs field, which is basically what gives certain particles their mass. And this Higgs field, it came into being right after the Big Bang.
So right at the beginning of the universe.
Imagine it like a cosmic syrup that fills all of space.
Cosmic syrup.
Yeah, bear with me. As particles move through this field, they interact with it. The stronger they interact, the more resistance they feel, and that resistance is what we experience as mass.
Oh, I see. So the Higgs field's like a drag on particles, and the more drag, the more massive they are.
Exactly. And finding the Higgs boson confirmed this idea. It was a huge validation of the Standard Model and gave us crucial insights into this fundamental part of the universe. And this is where the theories about CERN and reality shifts start to get really interesting, according to our source.
Okay, so we've unlocked this fundamental secret about mass. But the source brings up this interesting point about Stephen Hawking. He apparently said that the confirmation of the Higgs boson made physics less interesting.
Yeah, it's a famous quote from him. People interpret it in different ways.
Like he was disappointed or something.
Maybe a little tongue-in-cheek about how neat and tidy the discovery made things seem.
Oh, okay.
But the source points out something else. Hawking's Higgs boson doomsday theory, which he discussed in his lectures.
Higgs boson doomsday. That sounds pretty ominous. What is that exactly?
It's basically a theory about an instability within the Higgs field itself. The details are very complex, and it's all still theoretical. But the gist is that under extreme conditions, the Higgs field could shift into a lower energy state. And this shift could spread through the universe like a rapidly expanding bubble, and potentially, well, destroy everything.
So the thing that gives things mass could also lead to the undoing of, well, everything.
It's a pretty unsettling thought, yeah.
And the source connects this doomsday idea to the actual measured mass of the Higgs boson, which is 126 billion electron volts, right? They claim this puts the universe on the brink of instability.
That's the argument in the source, yeah. The idea is that this specific mass puts the Higgs field in a precarious position, like a balancing act.
Teetering on the edge.
Yeah, physicists call it a metastable state. And because so many particles get their mass from the Higgs field, if the field changes, even in one tiny spot, it could have a ripple effect throughout the entire universe.
And that could be catastrophic, I imagine.
Potentially, yes. So the source talks about this idea that, like matter, the Higgs field could exist in different energy states. And if enough energy gets concentrated, it could trigger a shift to a higher energy state. This would create this expanding bubble spreading at the speed of light.
And that bubble would change everything it touched.
Yeah, like a wave changing the properties of the entire ocean as it moves through it.
And if the energy goes past a certain point, I think the source mentioned a figure of 100 billion giga electron volts.
Yeah, that's the threshold, according to them.
That's when you get what they call catastrophic vacuum decay.
Right. And the end result. The end of our universe as we know it.
So we're talking about the complete annihilation of everything.
It's a pretty extreme scenario, but that's the idea. And here's where the concept of the multiverse comes back into play. Some physicists, the ones mentioned in our source, they've wondered, if this vacuum decay happens and our universe basically ends, where does all that energy and matter go?
It can't just disappear, right?
Well, that's the question. And one thought is that it might spill over into another universe. Remember, the idea is that these other universes might have different physics, different fundamental particles.
So our reality could merge with another one during this vacuum decay event.
That's one speculative possibility. Maybe a vacuum decay triggered by some incredibly high-energy event could destabilize the boundaries between universes, and then boom, our reality merges with another and we start experiencing these weird little inconsistencies, these Mandela effects.
So maybe we're seeing traces of another reality bleeding into ours.
It's a wild idea, but that's the suggestion. And our source even touches on string theory for a bit. You know, that idea that there are higher dimensions with all these bubble universes on their own membranes.
I've heard of string theory. Very complex stuff.
Yeah, it's incredibly complex. But our source uses it to suggest that maybe these bubble universes sometimes bump into each other or merge. And that could also explain the Mandela effects, these shifts in our reality.
Okay, so we've gone from misremembered cartoon bears to potentially universe-ending events caused by the most powerful machine ever built. I mean, could the LHC really be responsible for breaking our universe, as the source puts it?
Well, that's the central question they're exploring, isn't it? It's a whole chain of theoretical possibilities. The LHC influencing the Higgs field, leading to vacuum decay, and then the possibility of our universe merging with others, resulting in the Mandela effects.
It's a mind-blowing thought, but it's important to remember that this is all highly theoretical. As the source itself acknowledges, we're dealing with very complex ideas, and our understanding of the universe is constantly evolving. We're pushing the boundaries of quantum mechanics and cosmology here, where things can get pretty fuzzy between established science and speculative ideas.
Absolutely. It's important to keep that in mind. And we're really looking at one specific interpretation of these ideas here, connecting them to the Mandela effects, which are still a mystery.
It's definitely a thought-provoking look at some of the most fundamental questions about reality itself. And I think it raises even more questions than it answers. So, after hearing all this, think about it. Our universe might be this incredibly intricate system on a knife's edge, so to speak. And we humans, with our technology, are pushing the limits of what we know and what we can do.
It's definitely food for thought.
So what other unexpected consequences might our pursuit of knowledge have? It really makes you wonder, maybe this deep dive has sparked a curiosity in you. Maybe you'll go out and explore the world of quantum mechanics and cosmology a little further on your own.
Always good to keep asking questions
Exactly.
and keep exploring.
Thanks for joining us on this deep dive. It's been a wild ride.
It has.
Until next time.
See you